This is Mr. C, and this is Unit 1, Lesson 2, Growing Dots in our Algebra 1 Open Up curriculum. Our second lesson is a Develop Understanding lesson. So we're continuing on this path of trying to understand how to describe patterns. So for this lesson, our learning focus is to describe a growing pattern with tables, graphs, and equations. So for our launch, students, you're asked to mark up how you see the pattern growing in front of you. So students can come up with several patterns. The most important pattern, I think, there are two. So the first is to kind of notice that there's always one dot in the center of every pattern. And at the beginning, there's only one dot. But at minute 1, we have this dot added on each diagonal. And then, so from there, we have dots continuing to be added, 4 more on each diagonal, on each kind of like petal, right? And so we can kind of group these like so. So we're noticing that we have, for the petal pattern, right, we always have 4 groups of T dots, right? We're noticing that there's a relationship between the number of dots in each group, comparing that to the time, right? So at 1 minute, there's 1 dot in each of the 4 groups. At 2 minutes, there's 2 dots in each of the groups, so on and so forth. Another pattern that students tend to find, there's our first pattern. Another pattern that students tend to find pretty easily is that we always start with the 1 dot, that's true. But from there, we can kind of make this connection here. All right, there's this kind of like box pattern. And we ask ourselves, what is the relationship between the pattern and the number of minutes, right? Well, it turns out this box pattern always has T groups of 4 dots, right? So at the beginning, there's only 1 dot, but at minute 1, there's 1 group of 4 dots. At minute 2, there's 2 groups of 4 dots, so on and so forth. So if we were to continue this pattern, what would the pattern look like at 3 minutes? It would look something like this. So we're going to see here, we're going to have 1 in the middle, then plus 4, that's 5, plus another 4, that's 9 dots at 3 minutes. 9 dots at 3 minutes. Students, I urge you to make every effort in this unit to find a connection between the pattern that you see that's growing. How is that related to the minute? That is probably the biggest takeaway from this unit, having taught it for 3 years. Find a relationship between the pattern that you see and the number of minutes. Okay, so we're going to move on to our explore. So students are asked, how many dots are there at 4 minutes? How many dots are there at 100 minutes? Students can use either the petal pattern or the box pattern. I personally like the petal pattern. So we have 4 dots in T groups. So the petal pattern is T dots in 4 groups. T dots of 4 groups. So at 100 minutes, we're going to have 100 dots in 4 groups. So that's going to be 400 plus 1, since there's a 1 in the center. So we're going to have 400 dots plus 1. That's 401 dots. Okay, let's keep going. Okay, I had to do a little bit of rearranging. So how many dots are there at t minutes? There are 4t plus 1. Let's model this using a table. So t is my minutes. I'll say d is my dots. So at 0 minutes at the beginning, there's 1 dot. At 1 minute, there are plus 4, right? So 5. At 2 minutes, plus another 4, there's 9. At 3 minutes, there's 13. At 4 minutes, there's 13 plus 4, 17. So here's our table, right? So 4t plus 1 is equal to d, the number of dots. That's our table. I'm going to paste an image of our graph here in a second. It's a little bit difficult to graph this here, but we do know at 100 minutes, there will be 401 dots. So that means at t minutes, there are 4t plus 1 number of dots. Really important to see that. Here is a picture of our graph. So here's a picture of our graph. And let's think about this in 2 different ways. So here we have our explicit equation. How can we think about this recursively? Well, we know that we're always adding 4 to get from 1 minute to the next. So let's, for now, we'll say next term is equal to the previous term plus 4. Later on, we're going to have a more formal explanation here. Maybe I can zoom in here. And later on, f of n will represent the next term. F of n minus 1 will be the previous term, plus 4. And this is later on going to represent our common difference. This is going to be called the common difference, which is plus 4. It's the number that we're adding each time here, from 1 to 5 to 9 to 13 to 17, so on and so forth. So students have the opportunity to discuss their patterns. These are the 2 that I already mentioned. Okay, and then they would pause and record. They can students can graph this on their workbook and show that the common difference here is plus 4. So some takeaways can be recorded here for arithmetic sequences, which this is because we're adding 4, and recursive thinking, that recursive equation, right? What is recursive equation? It is using the previous term to get to the next term. For the exit ticket, students kind of explain what was helpful and what was not helpful, maybe what was confusing, what representation, graph, table, so on and so forth was confusing. And don't want to forget our vocabulary terms. So arithmetic sequence is a list of numbers in which each term after the starting term is equal to the sum of the previous term and a common difference. So 10, for example, is the sum of 3 plus 7. 17 is the sum of 10 plus 7. So the common difference here would be plus 7. So f of 1 equals blank, that's our starting term, so f of 1 would be equal to 3. Then f of n is equal to f of n minus 1 plus d, which is the common difference. So f of n equals f of n minus 1 will always be there, and what will change is the plus d, whatever our common difference is. Recursive thinking, noticing the relationship of one output to the next output. So here we have 6, then we have 12, then we have 18. So the common difference here would be plus 6. To get to the next one, you have to have a starting point and you have to have a pattern. So basically you're using the previous term to get to the next term. I'm not going to discuss the exit ticket since we actually just discussed it, and there's no really math. This is really just an opinion type of question, like, hey, what did you think? What did you think about these representations? So that's our second lesson called growing dots. This is going to build us up for future lessons. So be on the lookout for my future videos. All right. Thanks, guys. Bye-bye.